Hi, and welcome to our group's video on how to use the spectrophotometer. We scan all wavelengths so we can first determine the absorption spectrum, or what wavelengths a certain substance will absorb. We also scan so we can determine the purity of a substance. This is determined by the number of peaks present on the absorption spectrum. Finding lambda max. You find lambda max by scanning all wavelengths and locating the single highest peak on the absorption spectrum. Lambda max is specifically the wavelength where the light absorbance is maximum. To begin, transfer a sample of your diluted solution into a cuvette. When making your cuvettes, be sure to make a blank so that you can zero the spectrophotometer. Zeroing the machine. Use the blank cuvette to zero the spectrophotometer. We must do this because if we do not, then the machine would scan the absorbance of not only the substance we wanted to look at, but also the solvent and the cuvette. Here's the formula for Beer-Lambert law. A equals ELC. A equals absorbance, E equals molar absorbativity, L equals path length of sample, C equals concentration of the compound in the solution. How to find these values. A. Use a spectrophotometer to determine the absorbance of the substance. E equals slope. To find the slope, take the absorbance given to you by the machine for dilution number 2 and subtract dilution number 1 from it. Then divide this by the molarity difference between 1 and 2. L equals 1 centimeter. It is the length. C. To find C, rearrange A equals ELC to C equals A over EL. Here's an example. When cleaning up after this experiment, all solutions and any other liquids can be poured down the sink. All dried glassware and utensils should be put back where they go. Then you can wipe up. When all materials have been put back up and the surface of your lab area has been wiped down, your experiment is then complete.